Invert binary tree. Given a root of a binary tree, invert the tree and return its root. So, what is the invert binary tree all about? You just have to reverse this binary tree. So, usually, binary tree has a root child and root, and the nodes are left node and right node. So, these are the childrens of the binary tree. These are the childrens of the root. So basically, they just want to invert it. In simple terms, they want root to remain constant, but they want right to be over here and left to be over here. This is what they wanted. But in the picture, if you see the left also has its own left subchilds, that is left and right also has its subchild left and right. So how we are going to do with this? So to solve this problem, we can solve this with recursion. So it is very easy. Like 4 is the root, here is 2 and 7, right? And 1 and 3, then 6 and 9. So always remember, we first have to concentrate on the root nodes, sorry, on the children's. So once you swap this, that is 6, 9 and 6 will come towards this side, and 1 and 3 goes towards this side. Once you swap it, then you can swap the 2 and 7, and then we can do the invertery. So in general, these two nodes will be swapped over here, and these two children's will be swapped over here. So you can see in the picture, the 9 and 6 occurred at the left side, and 1 and 3 occurred at the right side. And after doing the swapping of the children's, then you can swap the roots. Again, these are the roots for these children's. So you can swap 7 goes over here and 2 goes over there. And then you can swap the root, then you can just give the root and generate the tree, which is an invert binary tree. So how can we do the approach? How What is the approach all about? It is a recursion. So for that, first you write the root node. Root should not be null. If it is null, then you have to return null only. I mean, you cannot invert tree if the root itself is null. And then first foremost, you have to invert these nodes, these roots. I'll show you. So first you have to invert these roots, 2 and 7. So first go ahead and invert the nodes 7 and 2, and whatever you are using the logic for 7 and 2, the same logic will be used at these children. This is what is recursion. Whatever formula you are using at 7 and 2, you will be using the same formula for your children's. That is what it is. And what is the formula? Same as what we always do for reverting, that is root.right equal to root.left equal to 10. That is what we'll write it into the code. It's very easy, and recursion is O of n times. So you just are calling the same function. Whatever you're using function over here, same function will be called for its children, same function will be called for its children, and that's how you get revert the tree and then return the main root. um let's go ahead and code it. So we need public tree node, invert tree, and we have given on a root over here. So if root is not null, what we are going to do, if root is not equal to null, we are going to call the function. What is the function all about? This same function. We are checking the null values, and we are going to call at both left and right side. So root dot left and root dot right. Now, what is the logic to do this? So the logic is, now you have to create tree node m equal to root dot left root dot left equal to root dot right, root dot right equal to 10. This is just we are inverting, and this logic we are using both at the left side and right side. And then you just simply have to return the root. Simple, you have to put a one node, left node into the temp, and then you have to invert. This is basically the invert line wherein you are reassigning the nodes, and then you are returning the root. And time complexity wise, it is O of n. That's it. Thank you.